Coming up in our global hunt for the greatest engineering catastrophes, a California dam on the brink of disaster.
I told my wife and kids, we need to go now.
A Scottish landmark that risked becoming a crossing calamity.
The lifespan of the bridge was a serious concern.
In Germany, a big build that's gone completely off the rails.
This is nonsense which has to be stopped.
And in England, a blazing end to the year.
It very quickly got serious.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings. These are the massive engineering mistakes that only an expert can hope to fix. With epic building blunders, the fail can strike when the welds are still warm and the paint is still wet.
It's a 360-degree problem, not just one for us.
But sometimes the root of the problem lurks hidden for years.
Over time, coupling actually split.
A ticking time bomb just waiting to go off.
And it hit like a mortar round. Boom!
Just like this construction calamity in California, an engineering disaster that threatened to wipe whole cities off the map.
It was panic. People were panicking.
I asked them if this is for real, and they said, yes, it's for real.
As disaster loomed, 180,000 residents along the Feather River were ordered to evacuate.
These people could have been less than an hour from annihilation.
California is known for its endless sunshine and 1,300 kilometers of coastline. But despite being right on the Pacific Ocean, it has a long history of massive water shortages. In the 1960s, work began on a solution near the small town of Oroville.
Most people have never even heard of Oroville, but it's actually home to one of the largest infrastructure projects in U.S. history.
Completed in 1968, the 235-meter-high Oroville Dam across the Feather River is, to this day, the tallest dam in America. Built from 140 million tons of mud and earth, the dam created Lake Oroville, storing more than 4 trillion liters of water.
The dam is vital, supplying farms, cities, and towns throughout the state of California.
But as with every dam, if water levels get too high behind it, there's a risk of damage or even catastrophic collapse, which could lead to massive flooding down the Feather River. Not only a threat to the nearby town of Oroville, but thousands of people living downriver towards the San Francisco Bay. So, the Oroville Dam has a safety valve in the form of 2 spillways.
When the water reaches a certain height, the water flows down these spillways so the reservoir doesn't overflow.
The main spillway is a concrete chute the width of a 12-lane highway. When levels in Lake Oroville are high, control gates are opened and the water is released, flowing more than 900 meters down to the Feather River. As a failsafe, there is a secondary emergency spillway beside the chute, a fixed ridge over which water would naturally spill if levels ever topped 275 meters before rolling down the hill to the river.
Spillway is a bit of an exaggeration. The second one is basically the hillside.
The dam functioned as planned for nearly 50 years, not only stockpiling fresh water, but preventing flooding and generating electricity too. But in 2017, Northern California experienced its wettest winter in more than a century. Lake Oroville was running at 151% of normal capacity. Journalist Risa Johnson heard rumors that all was not well with the dam.
On February 7th, we got a tip that there was something going on with Oroville Dam. Someone said that they might have seen a piece of concrete fly, so we thought something was up.
The main spillway was open, but was not only struggling to cope with the flow, it was starting to break apart.
The force of the water being released from the dam broke a huge hole in the concrete spillway.
A photographer got some pictures, and that was when we saw that there was a huge hole in the spillway. And so it just really escalated from there.
The main spillway was in serious trouble. Local pilot Gonzalo Curiel filmed the disaster unfolding from his light aircraft.
Most people in town, most people anywhere couldn't see the dam. I was fortunate enough, because I am a pilot and I do have an airplane, I could go up at any time and see it and get photographs and video of it. The main spillway being blown out, to see it from the air was spectacular, you know, in a sense, but it was also scary because we didn't know what was going to happen.
There was a lot of erosion going around the sides, and there was a lot of mud in the water, and it looked really bad.
Residents down the Feather River, like Genoa Wilder, were also getting nervous.
They noticed chunks, like big rocks, chunks of cement flying down with the water. And so that was the first, I mean, it was being shared all over Facebook, people were commenting, and that was the first sign that something was wrong.
Engineers were forced to slow the flow down the damaged main spillway. But the storm waters kept coming. Unable to drain quickly enough, the lake kept rising and was rapidly approaching the 275-meter maximum.
Seeing the storms coming in and how much water was coming into the lake and seeing how fast it was accumulating, that's when I started to get worried.
On Saturday, February 11th, 2017, for the first time in the dam's history, water started spilling over the lip of the emergency spillway.
The emergency spillway had never been used before. This was uncharted territory.
With the main spillway struggling, the second emergency spillway was the only hope for the dam to remain intact. But as the water flowed down the hillside, mud and rocks were also being washed down to the Feather River. By Sunday, the cascading water and debris had destroyed the road below. But much worse, the hillside was eroding fast. The emergency fail-safe spillway was failing. If the emergency spillway suffered a total failure, experts predicted a 9-meter-high wall of water would hurtle down the Feather River. The authorities were forced to order a mass evacuation of more than 180,000 people living downstream.
I think it was about 3 o'clock. People got that emergency 1 hour, you have 1 hour to get out, emergency evacuation order.
I asked them if this is for real, and they said, yes, it's for real.
Sounds like something out of a movie. 180,000 people were literally told to drop everything and flee for their lives.
The Oroville Dam was in real trouble. The emergency release spillway continued to erode as it struggled with the excessive amount of water from the recent storms. If it collapsed, the scale of the disaster would be unthinkable.
If it did actually fail and flood this area, those people would have been washed away. They said 50 minutes. And if within 50 minutes, if that would have failed, there would have been a lot of lives lost. When the evacuation actually happened, there was like a live countdown on the news of this is when it's going to fail, this is when the water is coming. And then there's this aerial footage of the highway heading out of town and cars just at a standstill.
While the water continued to gush down the hillside, engineers tried to reduce levels in Lake Oroville. The damaged primary spillway worked overtime. Gradually, the flow down the emergency spillway slowed, and hour by hour, the lake surface began to fall. 2 days later, the evacuation order was downgraded, and shaken residents were allowed to return to their homes. This close call highlighted two main engineering issues from the original construction phase. First, geological studies pointed at the hillside that the spillways were built on. In places, the rock was too weak to support the constant battering by water. As geologist Eldridge Moores demonstrates,
I can actually pick a piece off of this outcrop right here, and I can roll it around in my fingers, and I can make the rocks, disintegrate. The problem is the emergency spillway eroded in places that's as much as 20 to 25 feet deep in a week.
But geology wasn't the only problem. A forensic report found that a key cause of the main spillway breaking up was the concrete being too thin around drains in the chute.
The concrete in the main spillway was only 7 inches thick, about 17 centimeters. It was no match for the huge amount of water pouring from the reservoir above.
All told, the spillways suffered from several faults, from poor quality bedrock beneath to multiple cracks in the chute, which allowed water to flow underneath and cause yet more damage. With the immediate crisis over, engineers went to work on a solution. To create a solid foundation for the primary spillway, the weak rock beneath it was sprayed with liquid mortar, while thicker, stronger concrete walls were added. The eroded hillside of the emergency spillway next door was reinforced with a very different solution. A so-called cutoff wall dug into the slope. Holes were drilled deep into the solid bedrock, then filled with concrete, creating a robust terraced wall designed to both strengthen the hillside and slow the flow of water. Estimates put the cost of the emergency and repairs at $1 billion, but the dam and its spillways should be prepared for anything Mother Nature throws its way.
When, this crisis happened, they were all operating under the assumption that it was bedrock and that it wouldn't erode.
This isn't the only aging piece of infrastructure in the United States. The country is full of projects that need to be inspected.
Construction calamities can strike when they're least expected, with the original engineering errors hidden by history. But sometimes, things can go wrong while construction crews are still hard at work. For this story, we're off to Germany and a mammoth engineering development that's struggling to stay on track.
This is one railway that is definitely not running to schedule.
It takes so long, the costs increases.
Nobody think it's needed.
A runaway rail project that's 6 years and 4 billion euros over budget.
It sounds like this project has gone wrong in a very big way.
Stuttgart is at the heart of German manufacturing and the birthplace of one of the world's greatest inventions and engineering triumphs, the automobile.
Carl Benz and Gottlieb Daimler worked around this area. There is clearly precision engineering in the blood.
In 2010, construction started on a radical multi-billion euro station to speed up the city's railroad system. Transport specialist Christian Butger gets up to speed with the city's ambitious plans.
The idea was to get the main railway station in Stuttgart underground. In Stuttgart, we have a railway station that is like a terminus. The idea was that by putting everything into a tunnel, you wouldn't need to have to stop and to shunt anything, but just go through the city. It would allow the railway to get a faster connection to the high-speed lines that were thought to be built at that time.
The grand plan is to transfer the entire station underground, creating nearly 32 kilometers of new tunnels, and move from a terminus station to one that allows trains to pass under and straight through the city.
The main driver was not interest in railways, but the main driver was really city development. Stuttgart is in a valley, it's a growing city, and so they have a big pressure on real estate. By putting it into the tunnel, you could release quite a significant piece of land, and so the city of Stuttgart would love to have this additional city quarter for development.
The groundbreaking project was named Stuttgart 21 and due to be completed by 2019.
Smoother train journeys, fancier stations, real estate above. What's not to love about this?
It all sounds great on paper.
But the transformation of Stuttgart's main railway terminal into an underground station ran into trouble almost immediately. Right from the start, engineers faced a huge problem that existed long before the project ever got dreamed up: the rock beneath the city.
There is some concerns that the tunnel in itself will never be working properly due to this very unpredictable rock that is around that. And so an engineering company that did an investigation on behalf of Deutsche Bahn, they said there is an unusual big risk with this moving rock which is around that.
The geology around Stuttgart makes it really unsuitable for this kind of construction. There's something in there called anhydrite, and when that gets wet, it expands, and that's a real problem with this type of construction.
Millions of years ago, as ancient oceans shrank, crystals of the chalky mineral gypsum settled on the sea floor, forming beds of rock. When the sea evaporated, the rock baked completely dry, with gypsum turning to anhydrite.
Anhydrite comes from the Greek word anhydrous, which literally means without water. And like this sponge here, it absorbs water and expands. Definitely a problem when tunneling.
It sounds like Stuttgart is the last place you would want to put the lines underground.
Stuttgart's ambitious plan to transfer its central railway station underground was way off track. And with the project already suffering huge delays, engineers needed everything to run smoothly. But as well as unstable rock, there was another problem. This wasn't the only tunneling project in town.
Stuttgart already has a vast underground metro, so building any more tunnels is a logistical nightmare. They literally have to thread their way over and under the lines that are already there.
Local campaigner Werner Sauerborn gets to the bottom of the construction challenges.
What you see here is the S-Bahn. This is an urban train connection which goes this direction. And on the other side of the building side, we have another S-Bahn track. And now they try to bring the new tracks above those and under the other.
It's a huge engineering headache, and it's forced them to defy design convention.
To avoid the existing metro lines, they had to build the platforms at a much steeper angle than normal.
They are forced to have a big slope on the tracks. It's a slope of 6 meters from the point we are standing here to the end of the tracks. There are few stations in Germany which have a very small slope. And even on these stations, there are often accidents. Accidents with rolling wheelchairs, with buggies. And here we have a much higher slope than in other comparable stations in Germany.
By 2018, the project was 6 years behind schedule and 4 billion euros over budget. And for residents, the signals were there that this project would never be completed.
The 21 in Stuttgart 21 stands for the 21st century, but at the rate it's being developed, they'll be lucky if it's finished by the 22nd century.
There was a huge public discussion about that project, and probably we never had such an emotional discussion about an infrastructure project in Germany within the last 50 years. It really split the city.
Despite the billions being spent on the project, many experts claim that Stuttgart 21 will actually make public transportation in the area worse.
The old station had 17 platforms. The new one has only got 8.
No wonder people aren't happy.
Stuttgart commuters are still using the century-old station and are unconvinced that the new one will make things any better.
There is heavy doubts whether this tunnel now will have even the same capacity as the current railway system has. There was an estimate that for about 19% of the passengers going to or through Stuttgart, the project will get shorter travel times. For about 13%, it's going to get longer travel times. And for the rest, it won't make a difference.
That's not the end of the project's problems. It's rumored there's another burning issue they've yet to tackle.
Some believe that the station's fire safety system wasn't approved. So rather than hold up construction, they decided to put it off and add the system at a later date.
You would think that a project of this size would have sorted out something as important as a fire safety system from the very start.
Problems in construction mean the official opening date has now been pushed back to 2025. But with the troubles stacking up and a runaway schedule, some think that Stuttgart 21 should simply be shelved.
They are continuing a project which has no sense, which costs a lot of money. This is risky because it works in anhydrite and it has a platform with a much too high slope. So if you take all this together, this is nonsense which has to be stopped.
The planners, politicians, and project managers will all need to work together if Stuttgart 21 is ever going to be finished.
German engineering is the envy of the world, but in this case, it's gone off the rails.
When construction goes wrong, the mistakes can be massive without being a serious threat to life or limb. But sometimes, a small flaw can threaten a major catastrophe. For this story to Scotland and a bridge that nearly became an engineering catastrophe.
People did feel unsafe.
The lifespan of the bridge was a serious concern.
A crossing that no one wanted to cross.
I've heard of a bridge over troubled water, but this was a troubled bridge.
The River Forth, north of Scotland's capital, Edinburgh. In 1890, the Forth Railway Bridge was its first crossing and was heralded as a masterpiece of Victorian engineering. But with no room for vehicles or pedestrians, for over 70 years, if you didn't go by train, there was only one other, very slow way to get across. Engineer John Carson recalls.
I can remember as a boy here with my parents sitting on that south shore for 3 or 4 hours to catch a ferry over to just one of the villages on the north shore.
This all changed in 1964 when the Forth Road Suspension Bridge opened. The 2.5-kilometer long engineering marvel has two 69-centimeter thick main cables with hundreds of hanging wires to support the deck below.
The Forth Road Bridge was a huge achievement in its day. It was the longest bridge outside of the United States.
The two bridges wedded together to create an iconic impression on the Scottish landscape. But in structural terms, after just 4 decades, this honeymoon was over, as reporter Alan Roden discovered.
I was told by the people who worked there that the lifespan of the bridge was a serious concern. They told me that the bridge could be closed in as few as 10 years.
The rail bridge is still going strong after almost 130 years, but the road bridge was in trouble after just 50.
Nobody puts these bridges up and expects to get only 50 years out of them.
In 2004, the first large-scale inspection of the two main cables in the bridge's history revealed a concerning development.
There are thousands of cables in a bridge like this, and in the inspection in 2004, 22 had been found to have elements of corrosion.
They might look like single cables, but they're actually made up of over 11,500 thin wires.
22 corroded wires out of more than 11,000 might not sound like much, but it's too many to be ignored, as architectural journalist John Glenday explains.
You've got many thousands of cables all wrapped tightly together in bundles, and they're all taut tight. So unfortunately, it's not as simple as just going in and replacing individual snapped cables. The whole thing hangs together as a single entity.
Engineers needed to know what caused the corrosion. Part of the problem was how and where the main cables were constructed in the first place.
The major issue is Scotland's weather. It's very temperamental here in Scotland. As you can see behind me, we get a lot of damp, moist weather. That led to corrosion. We also get a lot of dry weather as well. It's not raining all the time in Scotland, despite what people may say. So you've got a real mixed climate here.
To make matters worse, during the entire 6 years of construction, the cables were spun together on site, exposed to the elements.
The wrapping and the spinning of that went on in all sorts of conditions, so you can imagine they were built in the wet and wrapped in the wet. So effectively what happens is that corrosion sets in.
The problem was, with the two main cables under constant tension, they couldn't physically be removed for repairs. So, to detect further corrosion, engineers installed acoustic monitoring equipment using microphones along the entire length of the bridge.
What you've got is a bundle of steel wires bound very tightly together. So if something snaps in the middle of that, you can't actually see it. The only way is to hear it. So you'll have sensors which can detect the sound of the cable actually physically snapping.
So every time a strand pops, it sets off an alarm. So they can actually tell now how many were breaking.
The 2004 inspections revealed an estimated 10% loss of strength in the bridge's cables.
The 10% failure rate on a piece of critical infrastructure like the Forth Road Bridge is a high margin.
Local cab driver Julia Fredrickson remembers the community becoming worried about making the crossing.
People did feel unsafe. They were frightened to go over, and I think especially the older generation who were like, oh, well, you know, what if anything happens when I'm on the bridge, not knowing how bad it was.
You know, people drive across this bridge. The idea that some of the cables that are holding their vehicle up are corroded, it's a worrying prospect for them.
Yes, Scotland's longest crossing was corroding, just 40 years after it had been built. But engineers had a plan. To stop the rot, technicians proposed a solution known as dehumidification. This had been used on similar bridges in Japan to great success.
The cables were covered and hot air was continuously pumped through, a bit like a giant hairdryer designed to remove moisture.
The rust could only thrive if the bundled cables were wet inside. Dry out the moisture and the corrosion is halted.
So the dehumidification process took around about 2 years at a cost of £8 million. It was a very innovative idea, and yes, it did actually work. It started to dry out the cables, which was a huge relief for the engineers involved in the Forth Road Bridge.
With the solution found, the Forth Road Bridge should have had a clean bill of health. However, there was another problem, which was putting a strain on much more than the cables.
When the road bridge opened, it carried around about 4 million vehicles a year. That was a lot, but it was designed for that kind of number, for a steady increase, but nothing like the massive increase that it saw.
Just 4 decades after its opening, the bridge was now carrying 6 times the amount of vehicles it was designed for.
The Forth Road Bridge had to cope with around 24 million vehicles a year, which is way more than it was ever planned to take.
That's 70,000 a day. That's a huge number.
To add to the bridge's already considerable load, the vehicles themselves had changed over the years.
The bridge itself was designed for 25-ton, 30-ton trucks maximum. This bridge now is taking 44-ton trucks. And the pounding that does to a structure like this is huge. So it not only exerts stress onto the cables and the hangers, but it also damages the decking, because the decking has supports in it spaced to cope with the old 30-ton lorries. It doesn't have spacing in it to cope with the new 44-ton lorries.
Despite the triumph over corrosion, by now, no amount of clever engineering could return the bridge to its former strength. So in 2011, the radical solution was to build another bridge.
This was the biggest transport infrastructure project in the whole of Scotland. It took 6 years to build. It was a phenomenal project, and in 2017, it opened to traffic.
At 210 meters tall, the £1.3 billion Queen's Ferry Crossing is the UK's tallest bridge, with a very different design to its troubled predecessor. A modern concept that spreads the load more evenly.
Here what we have is a mast. That mast basically holds up the whole of that structure from the ends of the cables there to the ends of the cables here. And it's built incrementally, one section at a time. And it's called balanced cantilever construction.
Balanced cantilever construction starts from the mast and works outwards, laying road sections on either side to maintain balance during assembly.
So effectively what's happening is all those little segments are being picked up and the load's being transferred up the mast and the weight's transferred down through the foundation.
The cables are laid in sync with the deck sections being placed and connected directly to the roadway from the mast. From the start, the cables are weatherproofed, acoustically monitored, and unlike its predecessor, any and all of the cables can easily be replaced. Architect Alan Dunlop believes the design is also a more stimulating improvement.
The thing about the cable structure is that, it provides a kind of elegance and very slimness to the structure itself. So not only do they perform very well structurally, it also gives a very beautiful and look to the bridge itself. So you look as though you have a bridge which is spanning over quite a large distance with a minimum of means, and it's very light and as a consequence of that, quite beautiful.
The Scottish Government wanted this, I think, to be a landmark project, and they've got a spectacular bridge. It is absolutely fabulous.
With the traffic pressure now relieved, the old Forth Road Bridge is back in business. Sort of.
The original road bridge was reopened, but this time only to public transport, pedestrians and motorcycles.
Today, this trio of functioning crossings offers a dynamic vision of Scottish engineering.
Far from competing, I think the three bridges in context add to each other, complement each other. We see through time as well as across the Forth. We see our Victorian ancestors and the work that they achieved, and we can also be proud that we're carrying that baton forward into the present day.
Building a whole new bridge is an extreme and expensive solution, but it does mean that Scotland has a state-of-the-art bridge that will keep the country moving for years to come.
For engineers, this is bridge heaven.
Construction calamities can be one-offs, a unique problem that can be put down to experience.
There could be up to 200,000 fatalities.
But sometimes, one fail is a reminder that engineering needs to keep on its toes. For this story, to England, and a blazing end to the year.
This is like a disaster movie come to life.
A shocking reminder that engineering has to move with the times.
Very quickly got serious.
This looks horrendous. It was a miracle that no one was hurt.
A catastrophe that created a scene of total carnage. Liverpool in northwest England, and it's New Year's Eve 2017. The city's main arena is hosting a huge event. At around 4:30 p.m., Sue Wright drove into the venue's already packed multi-story car park as disaster struck.
We looked to the right, and there was a row of cars parked, and behind that row of cars was a car on fire. And then everybody in front of us had stopped, and everyone panicked, and they just abandoned their cars and started running to the exit. The noise was quite intense. There was lots of bangs and pops of the explosions. You could smell the smoke. People were coughing. Within a few minutes, I think within about 7 or 8 minutes, the fire brigade arrived.
Local reporter Jenny Kirkham was near the scene and could sense a breaking story.
I was heading out to another job, and I thought I'll swing by and have a look and see if, what's going on. From then, you could see smoke coming out of the different floors. It was mostly on the 3rd floor, and then it spread. You could hear the pops of the fuel tanks in the different cars and things like that, but it was mainly contained and it looked like it was under control.
But inside, the fire was raging out of control.
Around 7, 8 o'clock, black smoke just filled all of this. Everybody was being pushed back because the smoke was getting so thick and it was spreading. And then from then, the massive flames just started bursting out of the car park.
As the inferno spread, the event was canceled. Around 4,000 people fled as the area was evacuated. Drivers were forced to abandon their cars, while residents in nearby apartments were also told to leave their homes.
It was quite frightening when that kicked off. It very quickly got serious here. What started off as pops of fuel tanks was turned into full-blown explosions. There was maybe 3 or 4 going at a time.
Hundreds of cars were now on fire inside the 10-year-old building. 85 firefighters battled through the night to extinguish the raging inferno.
It's not surprising because there were over 1,000 cars.
Although the blaze started in one SUV with a modified fuel system, more than 1,300 vehicles were destroyed. But amazingly, no one was seriously hurt. One fundamental problem may be the design of multi-story car parks, as fire engineering specialist Fatih Tarada explains.
We still, unfortunately, have the situation where a fire in a car park can be tantamount to the perfect oven. The flame from a burning car actually goes up to the ceiling, which is quite low, it's around 2.2 meters, and then starts to move horizontally. So the neighboring vehicles might have it from both directions, both from above and from below. So therefore, you can have an extremely dangerous situation.
In the mid-20th century, as more cars poured onto the roads, city center car parks grew upwards instead of out. These multi-level constructions could pack in more vehicles, but the combination of low ceilings, good airflow, and sheer number of cars risked turning a single car fire into a raging inferno. Although the Liverpool car park was only 10 years old, like all car parks in the UK, its regulations are based on vehicles from the 1960s. Cars have got much bigger, but the car parks haven't. Planning expert Russell Simmons explains why design regulations need to move with the times.
So the fire risk within buildings has certainly changed, along with the design changes associated with motor vehicles themselves. And the research that was undertaken most recently, which was several years ago now by the Building Research Establishment, was done utilising cars from years ago. And since that design change has taken place in cars, we must take that into consideration in the design of car parks. The risk has completely changed.
Car parks haven't really changed. The spaces are still the same size. You've got cars, SUVs, in closer proximity to each other. So the problem is, if you have a fire, you've got the fire closer to another flammable object, and that's going to cause a real problem.
With bigger cars, you get bigger fuel tanks and more fuel.
With the Liverpool car park packed with more than 1,300 vehicles, there was a huge amount of fuel just waiting to burn. But it's not just about the size of the cars or the car park. There's another issue with modern fuel tank design.
Another reason why cars are becoming more combustible these days is because their fuel tanks are now made from plastic themselves. So if you do have a fire from a neighboring vehicle affecting another vehicle, then if the fuel tank melts, it can release the fuel, and that in itself can become a hazard and can burn readily.
Car parks were constructed with petrol vehicles in mind, but since the 60s, there's been an explosion in the number of diesel cars on the road, which is likely to have made the situation even worse.
If you release diesel, it's more likely to pool, it's more likely to collect, rather than simply evaporate and dissipate. So it's more likely to flow into other areas that can catch fire.
Per litre, diesel has got around 10% more energy than petrol, which means it's going to burn for longer. It's also gloopier, so it sticks to things. So if you imagine it's burning, you're going to get burning fuel stuck to something. That's going to cause a real problem when you've got a fire.
Just a small amount of diesel can burn around 1,000 degrees Celsius, and that's around 1,800 degrees Fahrenheit. So it's no wonder the car park was an absolute inferno.
In this fire, what happened, as I understand it, is that the first tank will have blown, that will have then cascaded the fuel down to the next car, gone to the rubbers of the tyres, that car will have gone, and then it was a domino effect.
You can see how this spiraled out of control. You've got a slope in the car park, so all of a sudden you've got this burning diesel and it's able to move around all over the car park.
So, a combination of sloping access to each level, 5-decade-old design regulations, and a growing number of diesel cars all turned this city's celebrations into a flaming fiasco.
You can't change how every car is built or knock down every car park and start again.
One simple solution could be to install sprinklers, as is the norm in tunnels in the UK.
In tunnels, fire safety is heavily regulated, but in the UK, in car parks, there's almost no fire safety regulation.
As ridiculous as it may seem, it's not mandatory to have sprinklers in car parks.
Traditionally, there aren't many systems installed in car parks, and it's very rare to actually find a sprinkler system installed in an above-ground multi-storey car park. It's much more common underground, but there's no specific requirement for a sprinkler system to be installed in any car park.
Fatih Tirada demonstrates how effective a sprinkler system can be.
What we're going to do now is we're going to have a suppressed pan fire. So we will be using a fire extinguisher, and the fire will be contained within this metal gauze frame.
With burning fuel, the spray has to be foam, not water.
You can't put water on burning fuel. Fuel, oil, petrol, diesel just floats on water, so it's just going to spread everywhere. The key is to pour on foam. That starves the fire of oxygen, and it's going to extinguish it.
This is what we might have had if we'd had a sprinkler system in the car park.
Merseyside Fire and Rescue Service said a sprinkler system would have given crews a better chance of stopping the fire, while the mayor of Liverpool believes lessons need to be learned for the future.
Despite the raging fire, the car park did actually stay standing, and thankfully nobody got seriously hurt.
Had that car not been in there, that fire wouldn't have broke out and those cars wouldn't have been destroyed. So the car park did perform its function, but I think there is questions to be asked about car park safety and what we could do to stop this happening in the future.
Construction calamities come in all shapes and sizes, from the breathtaking to the groundbreaking, the stunning to the terrifying. So long as we keep building, there will always be more mistakes to fix.